Which of these are contained in the solution set to sine of x is equal to 1/3? And answers should be rounded to the nearest hundredth. Select all that apply. And so I encourage you to pause the video right now and work on it on your own. So I'm assuming you've given a go at it. Let's think about what this is asking. So they're asking, what are the x values? What is the solution set? What are the possible x values where sine of x is equal to 1/3? And to help us visualize this, let's draw a unit circle. So that's my y-axis. This right over here is my x-axis. This is x at 1. This is y, positive 1. -1 along the x-axis, -1 on the y-axis. Unit circle, I'm going to center it at 0. It's going to have a radius of 1. And we just have to remind ourselves what the unit circle definition of the sine function is. If we have some angle, one side of the angle is going to be a ray along the positive x-axis. We do this in a color you can see, along the positive x-axis. And then the other side, so let's see, this is our angle right over here. Let's say that's some angle theta. The sine of this angle is going to be the y value of where this ray intersects the unit circle. So this right over here, that is going to be sine of theta. So with that review out of the way, let's think about what x values, and we're assuming we're dealing in radians, what x values, if I take the sine of it, are going to give me 1/3. So when does y equal 1/3 along the unit circle? So that's 2/3. 1/3 right over here. We see it equals 1/3 exactly 2 places, here and here. So there's 2 angles where, or at least 2, if we just take one or 2 on each pass of the unit circle, then we can keep adding multiples of 2 pi to get as many as we want. But we see just on the unit circle, we could have this angle. We could have this angle right over here. Or we could go all the way around to that angle right over there. And then we could add any multiple of 2 pi to those angles to get other angles that would also work, where if I took the sine of them, I would get 1/3. Now let's think about what these are. And here we can take our calculator out, and we could take the inverse sine of 1/3. So let's do that. The inverse sine of 1/3. And we have to remember what the range of the inverse sine function is. It's going to give us a value between -pi/2 and pi/2. So a value that sticks us in either the first or the fourth quadrant if we're thinking about the unit circle right over here. And so we see that gave us 0. If we round to the nearest hundredth, 34. So essentially they've given us this value. They've given us 0.34. That's this angle right over here. How did I know that? Well, it's a positive value. It's greater than 0, but it's less than pi/2. Pi is 3.14, so pi/2 is going to be 1.57, and we can go on and on and on. So this right over here is 0.34 radians. But what would this thing over here be? Well, it's going to be whatever, if we go to the negative x-axis and we subtract 0.34, so we subtract 0.34. So if this is 0.34, we're going to get to this angle. So it's going to be, if we take pi minus the previous answer, it gets us, if we round to the nearest hundredth, it's 2.8 radians. So this is 0.34 radians. And then this one, let me do it in this purple color. This one right over here, if we were to go all the way around, it's pi minus 0.34. Which is 2.80 radians, rounding to the nearest hundredth. Now, that's not all of the values. We can add multiples of 2 pi to each of these. So 2.80 plus any multiple of 2 pi, so 2 pi n, where n is an integer. N is an integer. Or we could take 0.34 and add any multiple of 2 pi. So 2 pi n, where n is an integer. So our solution set here, just to rewrite it in a kind of outside of this messiness, is going to be 2.80 radians plus 2 pi n, where n is an integer, and 0.34 plus 2 pi n, where n is an integer. So let's see which of these are at least a subset of this. So we look at 0.34 plus 2 pi n, where n is an integer. Well, that's exactly what we wrote over here. So that's 0.34. If n is a positive integer, we'll go around this way, and we keep getting back to the same point. If it's a negative integer, we go around that way. We keep getting to the same point. But that's definitely in the solution set. 0.34 plus pi n for n, an integer. So if we have 0.34, and if we were to not add 2 pi, but just pi, where would we get to? Well, we would get to right over there. And the sign of this isn't going to be positive 1/3. It's going to be negative 1/3. So we could rule that out. Negative 0.34, well, that's this angle right over here. The sign of that's going to be negative 1/3. And if you add a multiple of 2 pi to that, you're still going to get negative 1/3, so that doesn't work. Same thing for this one right over here. 2.8 plus 2 pi n. That's what we wrote right over here. Going all the way to 2.8, and any multiple of it is going to get you back to that same point. So that one works. 2.8 plus pi n. So if you're here and if you added pi, you're going to get over here. And the sign of that isn't going to be positive 1/3. It's going to be negative 1/3. So we can rule this one out as well. So these are the only two apply. And if you actually take them together, you have the entire solution set to this equation right over here.